Here are two functions, one representing exponential growth and the other representing exponential decay. Here's the value of the function for exponential decay at time 0 and the value for exponential growth at time 0. And we've cheated a little bit here because if we're considering the functions e to the minus x and e to the x, plugging x equals 0 into those equations gives that f of 0 is equal to 1 for both functions. So actually the green line should be decaying from the same place as the blue line is starting from. So what we've done here is we've just expanded the scale on the f of x axis for the green line to make it look symmetrical with the blue line, and so that it doesn't have to start here, because if we drew it like that, which we could do, it just wouldn't show up very clearly. Now let's have a look at a property of the exponential decay curve in particular. Here's the value f of 0, and here is half of f of 0, and let's ask ourselves what value of x do we require to make f of x half of the initial value. Well, you may have seen things like that before, because if we replace an x-axis with a time axis, then that is what is meant by the half-life of an exponential decay, something that's commonly spoken about in radioactivity, for example. What's so special about half-life? Well, it's a constant feature of an exponential decay. So how long does it take to get from half of the initial value of the function to half of that? Well, half of f of 0 is a quarter of f of 0, and the time taken, or the value of the x-axis in this case, at which that happens, is the same increment along the x-axis as it was first time round. And if we carry on, we have another half-life. So what that means is that exponential changes result in equal fractional changes of the function for equal increments along the horizontal axis. And if the horizontal axis is time, and we have an exponential decrease, as in radioactivity for example, then the radioactivity will halve in a certain amount of time and halve again in the same amount of time afterwards.